I welcome you all, dear students, in this second class on analog and digital communication subject. Yesterday, we had talked about the basic concepts of electrical communication. We had also discussed the outline of the subject, how we be proceeding during the subject. And the first few classes will be a very introductory one, so that you are able to comprehend the concept of communication. And this assimilation of concept is very much important, so that you can understand the concept of the communication, electrical communication completely. Okay, and today's class will also be very introductory one, and all that you have to do is you have to give time to yourself to assimilate these concepts, and you have to give time for reading general things related to your analog and digital communication. Okay, so till the time we get too technical in the subject, I will advise that you read in general about electrical communication system or electronic communication system as much as you can from the reading material that I have supplied and the books that I have suggested to you people. Okay, and the more general you read, the more you will be able to understand about the communication. So in first few slides, I'll briefly revise what we did yesterday, and then we will continue with one more concept. So in the initial classes, we will go a bit slow so that you understand things clearly. But this going slow, you have to utilize this time in reading general thing for this subject. Okay, so I'll advise that once we are over with today's class, you have to complete the reading of chapter number 1 from book by George Kennedy. Title I have already told you, Electronic Communication System. You please go through that chapter so that you will be able to concretize your concept. So let us now move forward. So these are the books that I suggested you in yesterday's class. So the main slide that we discussed yesterday is in front of you. I told you that we are discussing electrical communication in this subject, which is different from the communication that you have studied in the subject on communication skills in English. There we were concerned with the mainly non-electrical form of communication, whereas in this analog and digital communication subject, we are concerned with the electrical form of communication. Okay, so I talked about information signal. Okay, and I told you that we need to transport this information signal from one place to another place. Now our objective is not just to communicate our ideas or our information to the person who is just sitting or present in front of us. We want to transmit our information or idea to a person which is very far away from us. Okay, so for that purpose we need electrical communication. I hope you understood this concept in yesterday's class, and I gave you one analogy also. The analogy was the general modes of transport that we use for commuting from one place to another place, that is car or ship or aeroplane. So similarly, if we want to transport our information from one place to another place through electrical means, we need an electrical carrier. Okay, and I told you briefly that this electrical carrier will be carrying our information signal from one place to another place, and obviously this electrical carrier will be having characteristics. That means it will be having a high power or a large amplitude or high frequency. Okay, next. Then we had talked about the basic block diagram of this electrical communication system. So this block diagram is a bit, you can say, technical one, quite different from what we have seen in the previous slide, which was more general. So students, here you need to notice two important things. One thing is that here in this basic block diagram, we have an entity that is labeled as transmitter and another is your receiver. Okay, so transmitter means which transmits and receiver means which receives. So your transmitter will be transmitting what? It will be transmitting the information. Okay, and receiver will be doing what? Receiver will be receiving the information. Okay, and obviously, as I told you, our objective is to transmit information from one place to another place, which are at a faraway distance. So that distance between transmitter and receiver is the large one. Okay, so this you have to keep in mind, that your transmitter and receiver, they are not sitting just next to each other. There is a large distance between your transmitter and receiver, and that distance between your transmitter and receiver, that has been represented by channel. So obviously our information will be going from transmitter to receiver through channel. Okay, channel means medium. Fine. So so mainly three things have come which were not in existence when we talked about one-to-one communication to a person who is sitting in front of us. We didn't require transmitter earlier. We didn't require receiver earlier. We didn't require channel earlier, or these things were not noticed. Okay, though these things were also implied. Now, if you remember from previous slide, I told you that we are talking about electrical communication. So obviously we need to reinforce our concept related to this term, that is electrical communication. So students, yesterday also I told you that the information sources which we have in a natural way, those information sources are non-electrical. Like your voice signal, or you can say voice, it is non-electrical. Your video source, it is non-electrical. Your image, it is non-electrical. But we have to transmit, whether it is voice, video, or image, to a faraway distance. So we will have to convert these non-electrical form information signals into electrical form. So unless we will be able to convert them to electrical form, we will not be able to transmit them from one form to another. So yesterday also I talked about this thing. So any non-electrical form of information will be converted to electrical form with the help of an electronic device that we call as transducer. Okay, so this is a general term and that you will understand in detail in a separate subject, maybe next semester or maybe in the present semester as well. So transducer will convert your signal from non-electrical to electrical, and the other way around also. It may convert from electrical to non-electrical, that we may call as reverse transducer. Okay, so transmitter we have already talked about in the previous class. That is, it is the transmitter that will help us in transmitting our signal through channel. Okay, and for transmitting our signal through channel, we need a carrier, as I told you in the previous slide. So transmitter, what it will do, it will help us in boarding our message signal onto the carrier. Okay, the way we sit inside a bus, like if you have to go to Delhi, say, you go to bus stand and you make yourself sit inside the bus, means you are boarding bus, which is a carrier. Similarly, your transmitter boards your message signal onto the carrier, that is electrical. Okay, so that was the purpose of transmitter. And another thing related to transmitter is, in fact, we had a discussion on this yesterday also, that we will have to prepare ourselves, like if we go by aeroplane, if we go by ship, or if we go by car, we make different kind of preparations. If you have to go via aeroplane, say, so when you move from home, then you will make certain kind of preparation, that you require for flying from one place to another place. Okay, so means your channel in case of aeroplane is different. Your channel in case of ship is different. Your channel in case of your car is different. So same thing applies to your electrical communication as well. If your channel is optical fiber, then you require different kind of preparation. If your channel is electric wire, then you require a different kind of preparation. If your channel is wireless, in fact, say there is no, wired medium in between, then you need a different kind of preparation. So this is also the job of transmitter, to make your signal compatible with that of the channel. So unless your signal is compatible with channel, your signal cannot travel. Obviously, like if you prepare yourself for going through car, but if you travel through air, how can it be? So obviously by boarding a bus, you cannot travel through air. Similarly, if you are going through air, how can you think of going through your bus? So that is the job of transmitter. So then we talked about channel. So yesterday we had a brief discussion on the channel. Now today I'll discuss this channel in a bit detail now. See, yesterday I told you that this channel, it will be introducing noise. Okay, so noise we already know in general meaning that noise is nothing but disturbance. Okay, so instead of calling that disturbance in electrical communication, we call that as distortion. Okay, or you can say interference. Fine. So when we, in the transmitter, what we do, we make our message signal board onto the carrier. Now our signal is ready to go in the channel. Okay, so when we say that, it means that our signal, or you can say information signal plus your carrier, these two things are fresh, totally fresh, without any distortion, without any noise. But as soon as my signal moves into the channel, it is subject to so much, noise, so much distortion. And in fact, let me tell you one thing more. Like if your channel is wireless, then in the wireless channel, what is the meaning of wireless? Wireless means space around us. Okay, so in that space around us, it's not only my signal which is present in the channel. It is everybody's signal present in the channel. Okay, so when my signal comes into the channel, then it enters into very harsh environment. Okay, let me try to explain this thing in another way. Say, students, as long as you are students means you are under the control of teachers, you are under the control of your parents. Okay, as long as you are inside your homes or inside your you can say university, you are not aware of that what is happening in the world around you. Okay, so your student life, your home life, it is very guarded one, very pure one. Okay, without much, disturbances, without any noise, kind of thing. And as soon as you become adult enough, and when you enter into practical life, okay, when you are no longer a student, when you go to earn your bread and butter in the practical life, then you really come across so many ups and downs in your life. Means you have to deal with every kind of noise present, every kind of distortion present. Okay, and what you have to do, you have to save yourself from that noise or distortion, one thing. Another thing is you have to basically make yourself strong enough so that that noise or distortion doesn't affect you. And after earning bread and butter, say in the morning, you go go to your office for your job. Okay, you go fresh from your home. As soon as you come out of your home, there is a lot of pollution, there is a lot of other things, and you remain in that noise or distortion throughout the day. Okay, and in the evening when you return back to your home, so what you do, you change your clothes, you take a bath, you try to become fresh again. So if you took bath, if you change your clothes, it means you have removed whatever extra, pollution, dust, etc. that was on you. You remove that and you again become fresh when you come back to your home. Okay, so that way you can say that your channel adds those disturbances, those dust on you when you move from, you can say, transmitter to receiver. Okay, so the job of the receiver is difficult because when you reach at the receiver side, you are exhausted because your signal has traveled from transmitter to receiver, which was at a very long distance. Okay, so we already know that when signal travels from one place to another place, the strength of the signal will come down. Okay, and added to that, signal strength has come down and noise has added. So what is the job of receiver now? The job of the receiver is to make the signal strong again. Okay, the job of the receiver is to remove that noise. Okay, and the job of the receiver is to give you fresh signal, which is free from noise, which is free from any kind of attenuation. So yesterday also I told you that it is the channel which is the there lies the climax of this movie. Okay, if channel is good, then we will consider ourselves lucky enough. If our channel is very harsh, okay, there is lot of noise, lot of disturbance, lot of distortion, then the job of the receiver becomes difficult. Okay, so at transmitter everything is fresh, so we need not think of much at the transmitter side. Okay, at transmitter side we have lot of things, lot of freedom with the communication engineer, whereas at receiver side communication engineer has to think of so many things. Okay, the communication engineer tries to retrieve the signal from so much noise distortion and also from distinguish from other user signal. Okay, so at the out of the transmitter, your signal will into the channel, then at the receiver side, and then obviously the output transducer, what it does, it convert our message signal back to, you can say, the original form from electrical to non-electrical form. Okay, so this was the basic block diagram of electrical communication system. Yesterday we had talked about this thing in brief. And today I will have added few more things into it. I hope this thing is clear to everyone. Now, see, again and again, I'm talking of the term signal. Okay, so yesterday I had pointed out what is the meaning of signal. So today I'm going to bit detailed discussion on it. So you can call signal as an entity, okay, which carries some information. Okay, and this entity we call as mainly an electrical entity. Okay, so this is a general definition of signal. Fine. Another thing is point number 3, that is your signal refers to time varying voltage, current, or electromagnetic wave, or some, you can say, any other parameter, but it must be time varying. So this thing you have to memorize, you have to remember that signal is nothing but signal is a function of time. All of you have studied mathematics. Okay, you know what is a function. So mathematically, your signal can be defined as a function of time. Function of time means it will vary with respect to time. So signal will always be a time varying entity. Remember this thing. Okay, and it will have some information associated with this. And let me tell you, this signal is mainly an electrical entity. Okay, you do not talk about signal in day-to-day life, in general life. Your signal has come into, you can say, picture only when we started talking about your electrical communication. Okay, so I have reproduced this basic block diagram at the bottom just to point out this thing. See, at the input of this block diagram, we were calling it as input message. There was no term signal. See, as soon as we convert that input message to electrical form, we call that as message signal. So here it is message signal because it has become electrical. Then in the transmitter also, your signal remains electrical one. Okay, so it becomes your transmitted signal at the output of the transmitter. So the signal that we are transmitting through channel, okay, this is also transmitted signal. Then signal travels through the channel in the electrical form or equivalent electrical form. Fine. Then at the input of the receiver, the signal that we receive, we call it as received signal. So again, it is signal. Okay. Then at the output of the receiver, again, it is signal, that is output signal. Okay. And when by using output transducer, we convert it into non-electrical form, it becomes your output message. So try to distinguish between this thing, that when we have non-electrical form of things, we call it as input message, output message. Whereas when we have electrical entity associated with it, we call it as signal. Okay, this is one point. Second point is, students, I have discussed this thing in the previous semester also. Mathematics is an integral part of any engineering subject. Okay, so that way, if we want to understand communication here, electrical communication here, then again, mathematics will be very, very important. So in this subject also, with the help of mathematics, we will try to understand things. And signal is first such mathematical quantity. Okay, whatever this electrical signal we are talking about, we will represent this electrical signal as a function of time. Okay, say st. St is nothing but a function of time. So mathematically, we'll call it as a signal. Okay, so wherever signal we talk about, we will represent that entity mathematically also. This you have to keep in mind. Okay, so see clearly towards your left hand side, we have three kind of signals. See, the signal at the top, it is called message signal, which is nothing but a simple sine wave. So you can see that it is varying with respect to time. Okay, and this is message signal. I told you in the previous class also that message signal has normally lower amplitude and lower frequency. So we call it as message signal. This is your carrier signal. This carrier signal is also, since we are calling it as signal, it is electrical entity. It is also varying with time. Its frequency is high and its amplitude is also high. Okay, and if you see in the block diagram, we are talking about transmitted signal. So this is your transmitted signal. This third one is your transmitted signal. Okay, and this is also varying with time. So these are and all these signals, all these three signals, message signal, carrier signal, and your transmitted signal, we can represent mathematically also. So these are all function of time. I hope all of you have been able to understand this thing. Okay, so till now we were concentrating ourselves onto the basic block diagram. Now we basically want to go in some more detail. So now we will talk about a further detailed block diagram. Let us see that it is not that detailed, but few more blocks have been added to this one thing. Second thing is, we were talking about transmitter in general, receiver in general, but transmitter in itself is not a simple block. It has many sub blocks in it. We need to look into it. Okay, I hope everybody has understood this. So students, this is the detailed block diagram of the same electrical communication system as we have seen in the previous slide. The main change lies here. What we have done, we have elaborated transmitter in a bit detail. So what we have done in transmitter, we have added two entities. One entity you can call as encoder and another entity as modulator. Okay, so you can here assume that we have divided transmitter into two further blocks. One is encoder and another is modulator. And students, remember one thing, in transmitter and receiver, things are reverse. So whatever happens in transmitter or whatever block is there in transmitter, almost reverse of that block will be always be there in the receiver. So in transmitter, we had encoder and modulator, whereas in receiver, we will have the blocks decoder and demodulator. So you can see modulator, demodulator, encoder, decoder. So now we need to understand that what was the need of this detailed block diagram. Okay, so see students, all of you understand communication in general. Our objective in electrical communication system is to transmit information from one place to another place. Okay, now if we have to transmit information from one place to another place, we have to basically take care of that our information reaches at the receiver side in the best possible manner. Okay, one thing. Second thing is our information should remain secure as it moves from transmitter to receiver, because see, when you move from one place to another place, you also take care of security. The luggage that you carry with you, you keep it in a secure place, you keep it under lock. If you carry money with you, you keep it with safety. So same is the case here with the information that we transmit through channel, we have to take care of its safety. So for that safety purpose, we need encoder. Right now, you need not worry about that why are we using two kind of encoders. Here there are two type of encoders which have been shown here. One is source encoder and another is channel encoder. But you simply keep in mind that we are using encoder. This thing we discuss in detail later on, that what is the meaning of source encoder and what is the meaning of channel. Okay. So obviously, if we need to encode at the transmitter side, we require a decoder at the receiver side. The main agenda of this block diagram, or the main objective behind this block diagram, is to clarify you people the concept of modulator and demodulator. Okay, so students, I told you in the previous slide that if we want to transmit our electrical signal from one place to another place, we need a carrier. Okay, so that requirement of carrier for message signal, for that thing we need to carry out a process, and that process is called modulation. Okay, so if I show you the previous slide again, see, I told you that we need an electrical carrier. Okay, and in the transmitter I had shown you this thing, that we will allow our message signal to board onto the carrier. So this process of boarding onto the carrier, this process is known as modulation. Okay, and the electrical block, or the block which carries out this modulation, is called as modulator. Okay, modulator is a block which carries out modulation. Okay, and since we are carrying out modulation at the transmitter side, we need demodulation at the receiver side. So these are dual of each other. So at transmitter, the main block which is present is, you can say, modulator. So modulator is an integral part of transmitter, whereas demodulator is an integral part of receiver. Okay, so this encoder, this decoder, these are, you can say, secondary blocks. The main block is the modulator and demodulator. Even some people say that transmitter is nothing but the modulator one, receiver is nothing but the demodulator one. And another, you can say, name for demodulator is also detector. Okay, so but since we are using the term modulation, that's why we'll stick to modulator and demodulator. Is that point clear? So in this detailed block diagram, what we have shown, apart from your information source and information destination, in the transmitter, we need to use encoder and modulator. And in receiver, we need to use the reverse of that. For modulator, we'll be using demodulator, and for encoder, we'll be using decoder. Okay, so modulator will be doing the process of modulation, and demodulator will be doing the process of demodulation. So the thing that I was talking about, that your message will be superimposed onto the carrier. That superimposition thing will take place in the modulator. Okay, so inside the modulator, there will be two signals. One is your message signal and another is carrier signal. And at the output of modulator, this will be the output of modulator. This is your output of modulator. And these are the two inputs to the modulator. So here in the block diagram, it is not exclusively shown, but you can, I can show here that at the input of modulator, there will be one carrier. Okay. I hope this thing is clear to each and everyone. So students, after discussing the detailed block diagram, now we need to understand what is modulation and what is demodulation. Okay, and this is very, very important slide, and this will answer many of your queries. I told you that in the transmitter, modulator is the most important part. Okay, so modulator does modulation. So modulation is very, very important term. So this is, you can say, the important part of transmitter. So this modulation takes place at transmitter side. We do modulation at transmitter side. Okay. Then second thing that you should keep in mind, as we have already talked about, that in the modulation, your message signal and carrier signal are superimposed with each other. As I told you that this is our message signal and this is our carrier signal. In order to transmit this message signal from one place to another place, we need to superimpose message signal and carrier signal. Okay, and once we superimpose, you can see here that this message signal is riding over the carrier signal. Okay, so this superimposition or interaction of message and carrier signal with each other, this happens during modulation, or this happens in the modulator. This is again and again, I'm trying to tell you that modulator or the modulation does the superimposition of message and carrier. And as I told you in the previous slide as well, that unless you make yourself compatible with the channel. See students, again and again, I'm trying to highlight this thing that this channel through which you want to travel, the characteristic of this channel and the characteristic of the signal that you are launching into the channel, that must match. As I explained in the previous class also, if you have prepared yourself for aeroplane, you cannot travel via car. If you prepare yourself for moving through ship, you cannot travel through aeroplane. You have to make preparations according to the channel. It means the signal that is at the output of the modulator, the characteristic of that signal must match with the characteristic of channel. See, if you are prepared for wired media, how can you travel, communicate wirelessly? If you have a wire with you, then can you think of transmitting wirelessly? So the kind of channel you have to match the characteristic of your signal with that of the channel. This I wanted to tell you here, that in fact, this is the real actual definition of the modulation. The actual definition of the modulation is, it is a process. It is a process which makes our signal compatible with channel. If your signal is not compatible with channel, your signal cannot travel through the channel. Okay, and this point is very, very important, that you have to match the characteristics of signal with that of the channel. If your channel supports high frequency signal, you cannot transmit low frequency signal through it. If your channel supports low frequency signal, you cannot transmit high frequency signal through it. So the characteristic of the channel and the characteristic of the signal that you want to transmit, their characteristics must match. That matching is important. And who does this matching? Modulation. And who does this modulation? Modulator. Okay, so if I ask you the definition of modulation, I'll call the definition of modulation like this, that modulation is a process which makes our signal compatible with that of the channel. In other words, it is a process which matches the characteristic of the signal with that of the channel. Either of the two things. This is one and the same thing. And I am trying to make you basically understand this thing again and again, that modulation makes your signal compatible with channel. If the two things are not compatible, then signal will not be able to travel. Your signal after modulation and your channel, their characteristic must match. Okay, then demodulation, I have already told you, it is the on the receiver side, and it is the reverse of modulation. Next is need for modulation. Why do we need modulation? One point I have already talked about in the previous slide, and which is the first and foremost requirement, that we need modulation to make our signal compatible with channel. For this purpose, we need modulation. Okay, so if you are traveling through train, then you'll have to make yourself compatible with train. You'll have to go to railway station. You'll have to board the train. You'll have to take a seat in the train. You'll have to follow the guidelines of the railway reservation. You are making yourself compatible with, you can say, train transport system. Only then you are able to travel through a train. If you want to travel through aeroplane, then in that case, you'll have to prepare yourself for traveling through aeroplane. You'll have to make yourself compatible with airport. You will have to make yourself compatible with aeroplane. Okay, that is point number one. This topic is very, very important, that why do we need modulation? That is need for modulation. First need is to make our signal compatible with channel. As I told you, that through channel, normally, in fact, when we defined electrical communication or the carrier, I told you that carrier will be a high frequency signal. And let me tell you here that if you want to transmit your signal in a wireless manner, then the frequency of your signal should be high. Okay, so for long distance transmission, we need high frequency signal. If a signal has low frequency, it cannot travel through your wireless space. Okay, so we need modulation, because with the help of modulation, we shift the frequency of the signal to higher value. Or in other words, you can say that with the help of modulation, we try to increase the frequency of the signal to higher range. Okay, so that its frequency becomes high and it is able to travel for long distance. Okay, so first need is our signal becomes compatible with channel. Second need is, with the help of modulation, we are able to shift the frequency of the signal to higher value. And third, very important need is, see, if we transmit our signal wirelessly, then what we need antenna. Okay, so what should be the height of antenna if we want to transmit? So obviously we need that the height of the antenna, it should be as small as possible when we transmit signal in electrical communication. Obviously, if antenna height is very large, it will be difficult to use and difficult to install. So that's why height of antenna is very crucial parameter for long distance wireless communication. And you should know this thing, that the height of antenna is proportional to quarter wavelength. Quarter wavelength means 1/4 of the wavelength. And we know that wavelength and frequency are inversely proportional to each other. So it means if we want smaller height of antenna, smaller height means smaller wavelength means frequency should be large. Okay, so if we want to keep the height of antenna smaller, we'll have to increase the frequency of the signal to be transmitted. Increasing the frequency of the signal to be transmitted means we need to shift the frequency of the signal to higher frequency range, which is nothing but again modulation. So we need modulation to keep the height of antenna to smaller values. That is another point because of which we need modulation. Okay. Then another important point for modulation is, see, I told you that this wireless channel or wireless medium is common to everybody. Okay, in this channel my signal is present, in this channel another somebody's else signal will be there, because this wireless space is common, environment is common, anybody can transmit his or her signal to this environment. Okay, so in the environment, in the wireless space, everybody's signal is present. So now when the signal reaches receiver side, receiver doesn't know from where the signal has come. Okay, so if this is the receiver which is receiving the signal. Okay, so at the receiver there are many signals which are coming. 1, 2, 3, all signals are coming to the receiver antenna. So how does receiver know that he has to receive the signal of user number 1, user number 2, or user number 3? Okay, so unless your receiver is able to distinguish between 1, 2, 3, receiver will not be able to receive that particular signal. Okay, so that means there must be some unique identity to every signal which is transmitted in the space or in the channel. Okay, and this unique identity is provided through modulation. How? I told you that in the modulation what we use high frequency carrier. Okay, so every user will be assigned a unique carrier frequency. Unique carrier frequency. If there are 10 users, every users will be given a different carrier frequency, and receiver knows which carrier frequency has been assigned to that particular user. So if this is the receiver for user number 1, he knows that his transmitter has transmitted at frequency F1. So he will receive only F1, he will reject F2 and F3. If this is the receiver for F2, it will receive the frequency F2, it will reject then F1 and F3. Okay, and that is possible only because we have used separate carriers or unique carriers for every user. So that's what we need modulation for. This modulation provides unique identity to each information signal. Unique carrier frequencies are assigned to each and every user. Okay, so I hope all of you have understood this thing. Okay, so see, unique identity, this is very, very important point that you need to understand. Okay, and another thing that you should understand, that why do we need unique carrier frequency? Because my voice signal and user number 2 voice signal, user number 3 voice signal, user number 4 voice signals, these voice signals are more or less same. Okay, there is not much difference in the frequencies of these voice signals, so it will be difficult to identify each and everybody's unique voice. So what we do, we assign unique carrier frequencies through modulation to each of these transmissions, and we will identify those signals or those information with the help of unique carrier frequencies. Okay, so you can say that these message signals and these carrier signals, these carrier signals will be different for different users. Okay, so I hope all of you have understood this. Now let us move forward. So here another important point that comes to us now, that if we need high frequency carriers, or you can say high frequency signals for information to travel from one place to another place, then why can't we transmit carriers? Why do we need message signal? See students, you were asking earlier, why do we need carrier signal? I asked you the reverse thing, that if carrier signal has to carry itself from one place to another place, what is the need of message? Why don't we send carrier directly? The question is, the carrier signal is, or you can say unmodulated carrier signal has constant amplitude, constant frequency, and constant phase. And my dear students, try to understand this thing. We have two things. One is message. Message has some information, and information is unpredictable. You do not know what I'm going to speak in next few minutes. You do not know how my voice signal strength will vary. You do not know what kind of information it is going to carry. But if I tell you that I have a sinusoidal signal of frequency, say 1 kilohertz, having amplitude 1 volt, then everything is known about carrier signal, because its amplitude is fixed, its carrier frequency is fixed, its phase is fixed. Information is variable, information is unpredictable, information frequency changes, information's amplitude is changing, but for carrier, for unmodulated carrier, we have constant amplitude, constant frequency, constant phase, and constant entities are predictable. Constant entities can be regenerated. So in case of your communication, whatever is constant, it does not have significance in terms of, you can say, its utility. So that way you can assume it like this, that your message is variable and your carrier is constant. Okay, we need to transmit this message signal through this carrier. So we need both. We need message as well as we need signal. So both are, you can say, indispensable for us. Okay, so that's why we cannot transmit high frequency carriers directly without modulation. I hope all of you have understood this. And here I have represented carrier signal with the help of mathematical equation. I hope all of you have been able to appreciate this. A is the amplitude of this carrier signal, omega c is the frequency, and phi is the phase. This is simple sinusoidal equation for carrier signal. Everything is already known to us, and see, we need communication to transmit those messages which are not known before. If I tell you that, okay, today is Sunday, you will say that, sir, this is known to us. There was no need to tell us that today is Sunday. If I tell you that tomorrow is Monday, again you will say that, sir, we already know this. This thing is predictable. Why did you tell this? You will not assume any significance to the information which is already known to you, which is predictable, which is constant. But if I tell you that tomorrow is Monday, but there will be holiday, so you did not know that tomorrow is a holiday. You had unpredictability in this message. It means this information is very, very important for you. So information which is unpredictable, or information has significance only when it is unpredictable, and your message is unpredictable, not the carrier one. So this is very, very important point. And that's why we need information. We need information to be transmitted through carrier. Okay, I hope everybody has understood this. Next. So now, in fact, today's main crux I have already covered. So I'll conclude with this last slide here. And here I would like to introduce you to some basic things which will help us in carrying out things further in the next classes. So one thing we have already discussed since the beginning of yesterday's class, that is information signal. Now I'm giving another name to information signal, that is modulating signal. So purposely I am telling you these terms so that you are able to familiarize yourself. So modulating signal is also called message signal. Your message signal is nothing but modulating signal. Your message signal is also called information signal. Your message signal is also called baseband signal. Okay, all these things, information signal, your modulating signal, baseband signal, message signal, these are signals without modulation. Okay, without modulation, before modulation. Fine. So you have to memorize these terms: modulating signal and baseband signal. Your modulating signal, baseband signal, these are your message signal. Okay. Next is your carrier signal. So carrier signal I have already talked about. Your carrier signal has fixed amplitude or frequency or phase, and this carrier signal is unique for each transmitter and receiver, and this is our carrier signal. Okay, so we have this message signal which we call it as modulating signal. This is our carrier signal, and next is our modulated signal. Modulated signal is this one. Means if you make your information signal board over the carrier, means if you superimpose modulating signal and carrier signal, what do we get? We get modulated signal. Okay, remember this, modulated signal. So we have modulating signal which is superimposed onto the carrier signal, and we get modulated signal. See, focus on this. Amplitude modulated signal means the signal which has been obtained through amplitude modulation. Modulated signal means signal obtained after modulation. Modulated signal, that will go through the channel. Okay, so it will travel through the channel. Modulated signal, that will come out of modulator. Okay, say if this is the modulator, this is your modulated signal. This is modulated signal. Okay, at the input of the modulator, you have modulating signal one, and another will be the carrier. Okay, so we have modulating signal, we have carrier signal, we have modulated signal. Then we have demodulated signal. Demodulated signal means the signal after demodulation. So this was your modulated signal, and this is your demodulated signal. Once you have demodulated, you get demodulated. Okay, and then bandwidth, you must have heard of very commonly. Bandwidth means the range of frequencies. Okay, so if you are able to transmit from F1 to F2, okay, so then F2 minus F1, your higher frequency minus lower frequency will gives you the bandwidth. Okay, I'm talking about channel again and again. So channel means every channel has a bandwidth. So means every channel will be having some high frequency, some low frequency, which it will be able to transmit. So if you subtract those frequencies and if you obtain the range of frequencies, that will be called as bandwidth. Okay, then another important term is instantaneous value. So you look carefully at this sinusoidal equation. Your A is what? Amplitude. This is your sinusoidal signal. Omega CT, where omega C is your carrier frequency that you already know. Phi is phase. Now what is this VCT? Okay, in fact it should be small VCT. If you write a sinusoidal equation, you write like this. Like we write small VCT, okay, equals to capital VC sine then omega CT, okay, and plus phi. So if you have such thing, then you look at this sine wave. So if this is your sine wave, fine, then the maximum value of this sine wave, that is amplitude, that maximum value is VC. So this is your amplitude, maximum value, amplitude of sine wave. Omega C is your frequency of this sine wave, phi is the phase, and what is VCT? This is instantaneous value, means the value at a particular time t. So this is your time axis. So instantaneous value, this will be instantaneous value, this will be instantaneous value, this will be instantaneous value. At a particular time t, whatever value you get, that will be instantaneous value. So you must understand the difference between instantaneous value and this amplitude is nothing but the peak value. This is the peak value. Okay, so I hope all of you have understood this thing, and that's all about today's class. Okay, so I hope all of you have understood this concept of electrical communication, the basic block diagram, and a bit detailed block diagram, then the need of the modulation and the small terminology. Fine. So students, I stop here.